Hello everyone. This video is on the Knewton Alta assignment for section 6.2 called Exponential Function Graphs. In this video I'm going to be going over a preview version of this assignment, so I hope you understand that the questions I see in this video may not be exactly the same as the questions that you see when you work on the assignment yourself, but all the objectives are the same, the structure is the same, so I'm hoping that watching me do these here helps you in some way when you work on the assignment yourself. Alright, so the assignment page, you should see the title, the mastery bar telling you how far along you've gotten, all the objectives. It looks like there are 4 objectives for this particular assignment. Under the current objective, right, there should be a question related to that objective. And at the bottom of every question, there should be a feedback button. You can send feedback to Knewton if you wish. There's an instructor cheat button that you will not have. Alright, this is for instructors only. This will not be there. But you will have the More Instruction button. If you're struggling with a topic or question, click on this. It'll take you to a page with some more reading or videos to study, and then you'll be given questions related to that instruction, and completing those questions correctly will progress you through the assignment as well. Alright, so this first objective I'm looking at, graph exponential functions using transformations. Alright, so I'm going to be assuming some things here that you remember all the graph transformations from chapter 3, all the chapter 3 stuff, chapter 3 assignments. I mean, I'll discuss them, I'll bring them up again, but I'm not going to go over function transformations as in depth as I did back in the chapter 3 sections. Alright, so very simply, we're asked to graph the function f of x equals 3 to the x minus 2 power by moving the key points. So they have these 2 points that we need to move around. Really, you just need to move them to points that would be on this graph. But yeah, so let me discuss what the transformation they're talking about here is. So on paper, we're given this function f of x equals 3 to not just the x power, but the x minus 2 power. So hopefully you recall that a basic exponential function, the one we're going to start with if we're graphing using transformations, the most basic version of an exponential function would be like this: y equals, or f of x equals g of x, whatever, b to the x. This is the most basic version you could possibly have, and of course b is a positive number. We're going to deal only with positive bases. And so this will be our starting point, some function that looks like this. And then we'll perform, transformations, horizontal shifts, vertical shifts, horizontal compressions or stretches, vertical compressions or stretches, reflections across the x-axis or y-axis, and that's really all of them that we've studied. So for this one here, base of 3, the parent function, the starting function, before I perform the transformations, will be y equals, just 3 to the x power. Alright, and the graph of that, you should know what the graphs of these look like by now, after section 6.1. But I'll just draw it up here. 3 to the 0 power is 1, so it would have 0, 1 on it. 3 to the first power is 3. So it has 1, 3 on it, right? 3 to the negative 1 power would be a third. Alright, 1 over 3, and it looks like this. The graph would look something like this. And I'll also go to that Desmos website to give you a better picture. There's the graph of y equals, 3 to the x power. It's got a horizontal asymptote of the x-axis, domains all real numbers, the range is all positive numbers, and it's an increasing function. Now, the only thing that would need to be done to change this function, this expression, into that expression is I'd replace x, right, the 3 to the x power, I replace the x with the quantity x minus 2, and now I have f of x. Right, f of x would be 3 to the, instead, again, x is replaced with x minus 2. Now, do you remember what transformation that causes? If I replace x with x minus h, if h is a positive number, it moves to the right. If h is a negative number, it moves left. Well, x minus h here, x minus 2, that's a positive 2. Replacing x with x minus h in the previous function gives me a horizontal shift. Causes a horizontal shift, and that would be to the right 2 units. Right, so that graph there, instead of 0, 1, you'd have 2, 1. Right, 2 units. And you could think about that, replace x with 2, right, that would give me 3 to the 0 power, which would be 1. Output would be 1. And instead of 1, 3, you'd have 3, 3. Right, move to the right 2 units. And everything would move to the right 2 units, and I'd get this graph here. Right, it's the same shape, just to the right 2 units. Right, there's 3 to the x minus 2 power. And that's the graph we want. And so these points they gave us, we'll just move them over here to the point 2, 1, and 3, 3. Right. And again, you don't need to really remember the transformations all that well. If you just plug in values for x and get outputs, you'll be able to plot points. If I plug in 2, I'd get output of 1. If I plug in 3, that would give me 3 to the first power, that'd be an output of 3. Right. And like I said, I'll go to that Desmos site and show you a better picture. So this is that free online graphing calculator at desmos.com. Alright, here's y equals 3 to the x, alright, that I showed you. There's 0, 1, right, here's 1, 3, and so on, right. And if I, again, just replace x with x minus 2, oops, make sure the minus x minus 2 is in the power. And you see the blue graph that just came up, or whatever color you see. Every point on the blue graph is just the point on the red graph moved to the right 2 units. Here's 0, 1, and there's 2, 1. Here's 1, 3, there's 3, 3, right, like I showed you on my hand drawing. Still the same horizontal asymptote, right? The x-axis is still a horizontal asymptote. The only time the horizontal asymptote changes is if you shift up or down, which hasn't happened here. Alright, so back in the assignment, like I said, I'm just moving these points. Here's 0, 1, I'm moving that over to 2, 1. And here's, 1, 2, I'm going to move that over to, remember 3, 3 was on the graph. Instead of 1, 3, it was 3, 3. So there's, 2, 1, 3, 3, those are on the graph, and that's all I need. And it's an increasing function, domains all real numbers, ranges all positive numbers, the horizontal asymptotes, the x-axis, it's got all that stuff. And then I submit. And then after you submit an answer, you'll be told if you're correct or incorrect, and then be given some sort of answer explanation. Please read through the answer explanations below here, just to make sure you understand why something was correct or incorrect, and hopefully you can learn from your mistakes for future questions. Alright, next question. Alright, so now we're just in straight up graph exponential functions. So this is a multiple choice one here. Alright, but I'll just, I'll graph this one by hand, and then, for most of them, I'll just go to the Desmos site and we'll take a look at the graphs, but you should also be able to know how to graph these by hand. Alright, so the function we're given, f of x equals, now this time the base is less than 1. Alright, it's 1/8 to the x, right? This is one of those basic exponential functions like I had on the previous page, right? The y equals base to the power x. Now we saw here, when the base was 3, it was an increasing function. What you're going to see here, when the base is less than 1, like 1/8 here, it's going to be a decreasing function. If I go, make a little xy plane here, anything to the 0 power is 1, so 0, 1 is on the graph. 1/8 to the first power is just 1/8, so very tiny, right? So like say that's here, and then 1/8 to the second would be 1/64, even tinier, and then 1/8 to the third, 1/8 to the fourth. As you move to the right, the output decreases, right? You are decreasing, going down. Now it never actually touches the x-axis, right? Remember, the x-axis is a horizontal asymptote for these basic exponential functions, but it is decreasing. And then remember, negative powers are just the reciprocals of the positive powers. So 1/8 to the -1 is just 8, the reciprocal of 1/8 to the +1, right? Right, so -1, 8, right, and then -2, 64, -3, 8 to the third power, right? Really gets really fast. 512, right? But it goes up real fast as you move to the left. But if you go left to right, they call it, a decreasing function. So there's again a very basic graph of this basic exponential function, and again we can see this in Desmos more clearly. So just getting rid of this stuff here. Y equals, or f of x equals, 1/8 to the x, and you see the decrease for sure. Right? 0, 1. I could make a little table here. Have a table pop up. See -2, 64, -1/8, 0, 1. 1, 1/8. 2, 1/64. And again, it's not actually touching the x-axis ever. It's always a little positive. It's always a little bit above it, and you can zoom in closer and closer and closer and eventually see that, yes, the graph doesn't touch the x-axis, right? That's a horizontal asymptote. Alright, so looking back at the multiple choice options, definitely not this first one. That's an increasing function. It may be this one. Right, and it looks like input -1, output 8, 0, 1, and it's decreasing. So it looks like this one's the correct choice. This is increasing. This one is decreasing, but look at the input and outputs, right? Input -1, output 3. Right, the output should be 8. So not that one. Here, input -1, output 1. Again, the output should be 8 when the input's -1, so it's not that one. Here, this has a y-intercept of 0, 2. It should have a y-intercept of 0, 1. Yeah, it's decreasing, but it has the wrong points on it. So the one I selected is going to be the correct choice, right? 0, 1's the y-intercept. -1, 8 is on the graph. It's decreasing from left to right. Looks good. All right. Great. All right, next question. Right, so now we're in this other objective, right? There are 4 of them. Write an exponential function from its description. So once again, you're going to have to know how the function transformations work from all the Chapter 3 material. Right, so if you don't recall that, go back to the Chapter 3 sections and refresh your memory. Alright, so we're given the function y equals e to the -x power and then told to do all these transformations to it, what would the final expression look like? All right, so I'll write this out. And we'll go through the Desmos site and look at and make sure that the transformations that are described are actually happening. So we're starting off with this, y equals e to the negative x. Then they say vertically stretched. The first transformation is vertically stretched by a factor of 2. Now remember, vertically stretched by a factor of whatever is just you take the previous expression and multiply it by that number. So it's just y equals 2 times e to the negative x. That's going to cause a vertical stretch by a factor of 2. It's that simple. Vertical stuff is usually pretty simple. Next, the next transformation is reflected across the y-axis. Reflected across the y-axis. Now, reflecting across the y-axis, remember, is a horizontal transformation going across the y-axis. And that's where basically just x is replaced by the opposite of x. That'll cause a horizontal reflection, a reflection across the y-axis. So we have y equals, 2 times e to the opposite of, and then x is replaced by the opposite of x, and then you'd like to simplify this, I'm sure. The negative x is just x, right? So this is y equals 2 times e to the x power. The graph of this would be the graph of our previous line reflected across the y-axis. And then shifted down 3 units. Just a vertical shift, right? Shifted down 3 units. And remember, the vertical stuff, you just leave the previous expression the way it is and do something on the outside. While shifting down 3 units is just subtracting 3. Y equals 2 times e to the x, and then minus, leave the previous one the way it is, and then just put a minus 3 outside it. And let me go through in the Desmos site and see that all this stuff actually happens. Alright, so back here, so again, the original function we were given was y equals e raised to the negative x power. Alright, so it looks like this. Got 0, 1, negative 1 e. Remember, e is about 2.7 something, right? Then positive 1 would be 1 over e, alright, whatever that is. So you got that function there. Then we said, vertically stretched by a factor of 2. So y equals 2 times e to the negative x. So you see now all the points on the new graph, this blue graph, again, whatever color you're seeing, are just the points on the red graph where the outputs are doubled. Right? The distance from the x-axis to the red graph is doubled to get to the blue graph. Right? That's a vertical stretch by a factor of 2. Okay, great. Let me turn this one off. And then we reflect it across the y-axis. So I replaced x with negative x, and negative x made just x. All right, we had y equals 2 times e to the x, and see this green graph here, again, whatever color you're seeing, is just the blue graph. All the points are just reflected across the y-axis. I hope you can see that reflection across the y-axis. And then finally we took this one and shifted it down 3. Y equals 2 times e to the x, and then minus 3 after. And you see this purple graph there, again, whatever color you're seeing, but you see the purple graph show up. And all the points, this has 0, 2, this has 0, negative 1. It's just, all the points are moved down 3. And this is the moment where the horizontal asymptote changes, right? You may notice that the horizontal asymptote for the green graph is the x-axis, but for the purple graph it's just y equals negative 3, right? the horizontal asymptote got moved down 3 as well. And that's the only time the asymptotes get moved, is if you move up or down, vertical shift up or down. Alright, but there's our expression. It looks good. Looks like all those transformations actually did occur. So we ended up with y equals 2 times e to the x, and then afterwards minus 3. Great. Alright. Next question. Alright, back to just graphing exponential functions. Graph the function y equals 1/7 to the x by moving the key points. Alright, and you can only graph integer points, so like 1/7 to the 0 power would be 1. So 0, 1 I've already got. Alright, I'll just leave that there. Now if I put 1/7 to the first, that's 1/7, but you can't move these to integer, you can't move these to fractions like 1/7. So I'm going to go backwards, go 1/7 to the negative first power, that would be positive 7. So move this point to negative 1, 7. And there we go, right? There's negative 1, 7. Here's 0, 1. Those would be points on the graph. And remember, if it's a basic exponential function, just b to the x, and the base is less than 1, it is a decreasing function like this. And you know, look, everything looks great. Good. All right. Next. Alright, so this was using transformations. Remember, y equals 3 to the x, but then plus 2. So move the key points and the horizontal asymptote. So remember, 3 to the x has 0, 1, and 1, 3, but then you just move those up 2. So 0, 2, which, 0, 1 would move to 0, 3, and 1, 3 would move to 1, 5. And then the asymptote would move up as well. Ah, I see what they're doing. Okay, so let's move the asymptote first, right? So the asymptote, instead of being the x-axis, will move up 2 units. So it's y equals 2 here. And then you move the points. So let's do that instead. So yeah, you'd have 0, 0, 3, right? Instead of 0, 1, it would be 0, 3. And instead of 1, 3, you got 1, 1, 5. Right there, those should be good. Right? 1, 5 would be on the graph. You can plug in 1 for x, you get 5 for y, and plug in 0 for x, you get 3 for y. And there's the line. It's the point 0, 2, but there's the line y equals 2. Right? Where again, the only time the asymptote's moving is if you have a plus or minus some constant at the end, like the plus 2 here, and that should be good. Right? Those should be relatively simple. But yeah, after the way it looked like it moved, I would suggest moving the asymptote first, and then the points. Alright, so this one's writing in a function from a description. Alright, so again, I'll start with the function they gave us here. This time I won't go through Desmos. Alright, I'll just perform the transformations and write the expression. So we're starting with y equals e to the negative 3x, and it has to perform all these transformations. Alright, so let me do that. Alright, so I'm starting with y equals e to the negative 3x, and then performing some transformations. Now the first one is vertically compressed. I don't like the way they're wording this. Vertically compressed by a factor of 4. Compressed vertically would mean all the points get closer to the x-axis, right? Like here's the x-axis. All the points would move in closer to the x-axis. Compression. But by a factor of 4. 4 is bigger than 1 though. So I think they meant to have 1/4 here, but if they do have a number bigger than 1, just do the reciprocal of it if they say compressed, right? So this is just multiplied by a 4th. y equals 1/4 e to the negative 3x. This function will have points that are a quarter of the distance, they're closer to the x-axis than the original function. Then reflected across the y-axis, we saw that already. Let's just replace all the x's with negative x, which would make this positive 3x for the power. Y equals 1/4 times e to the negative 3 times negative x, which would be positive 3x. That reflects it across the y-axis. Then shifted down 5 units. I'll just do this after here. Then it says shift down 5 units. And so just throw -5, and there's the final. That's the final function they're looking for then. Okay, and again, you can go to Desmos and see that all those things actually happen. Now, again, I'm confused. I was a little confused here. They put compressed, but then have a factor number bigger than 1. Compressed should have a factor number but less than 1. But if they put a number bigger, so I'll say this to you: if they put a number bigger than 1, just multiply, do the reciprocal. Let's see. I'm hoping that I'm reading that correctly. So we ended up with 1/4 e to the 3x and then -5. Yeah. So again, the key word there was compressed. That's why it's 1/4, not 4. Right. If they said stretched, then I would keep it as 4. Right. Stretching is by factors bigger than 1. Compressing is by factors less than 1. Okay. Now the last objective we haven't seen, find the equation of an exponential function, given a graph. So here we're given a graph here and asked to write the equation for it. Now we actually saw something like this in section 6.1. I believe it was 6.1 part 1. So I really just need 2 ordered pairs here. And it looks like I've got 0, -3, and 1, -6. Also 2, -12 are on this. I mean, there's lots of points, but you just need 2 points really. So remember, our general exponential function, not the basic one, but the general one, was f of x equals a times b to the x, where a was called the initial value. Right, this is the output when x is 0. So the point 0, a is on the graph, and b had to be positive, right? That was also the base, and not equal to 1 as well. Right? You can't have a base of 1. That's uninteresting. And you just need to find a and b, right? Given 2 points. Well, we know 0, -3 is on this graph. Also, we have the point 1, -6 is on the graph. So I know that a is -3. All right, so now we have f of x equals -3 times b to the x. And now I just need to find b using this point. -6 is the output, so that replaces the f on the left side. Equals -3 times b to the first. Right, x is 1. And then b is clearly +2, dividing by -3 on both sides, and then I pop that in. Right, and we get our function, f of x equals -3 times, and then 2 to the x power. Right, now, if the horizontal asymptote wasn't the x-axis, I'd also be putting plus or minus something afterwards. But we'll see. Maybe we'll see something like that later. But here the horizontal asymptote is the x-axis, so the function has to be like this. It can't, but if the horizontal asymptote wasn't the x-axis, it was moved up or down, then I'd have some, plus some number afterwards. All right, but that's it. F of x equals negative, and you can go to Desmos and check it, make sure, -3 times 2 to the x power. Great. Next. Alright, so another one like that. Find an equation, and once again, here the horizontal asymptote is the x-axis, so it's got to have that a times b to the x form, and it's got the point 0, 1. It's got the point 1, 2, 2, 4. This is just 2 to the x. F of x equals 2 to the x. I can very easily see that, and hopefully you could too, but it's just f of x equals 2 to the x, this one. Okay. Now we're back to this graph, exponential functions. Now it's not 7 to the x, it's 7 to the negative x. So it would still have 0, 1. Right? If x was 0, the output would be 1. But if x were 1, the output would be 7 to the negative 1, which is 1/7. So I have to go backwards to get integers. If x were negative 1, it would be 7 to the positive 1. You get an output of 7. So it has negative 1, 7, 0, 1, and would be decreasing. Again, you can do, negative 1, 7. So that's 0, 2. Here we go. Negative 1, 7, 0, 1, decreasing. This graph here. Right. Again, you play around with it, mess around with it, plug in values, do it by hand, go to Desmos, but you would end up with a graph that looks like this for 7 to the negative x. All right. Next. Alright, so it looks like this is exactly the same thing. 7 to the negative x and 1/7 to the x are the same function. Alright, let me show you. Using some properties of exponents. Y equals 7 to the negative x. That's exactly the same as 7 to the negative 1 to the x. Remember that power to a power property for exponents. You would multiply these, get negative x. And what is 7 to the negative 1? That's 1/7. So that problem we just had was 7 to the negative x. That's the exact same function as 1/7 to the positive x. So it would have negative 1/7 on it, like this one does, 0, 1, and be decreasing. It's this first option. That first option is the one that matches the graph from last time too. Great, so that objective's done. Graphing basic exponential functions should be simple, in my opinion. Alright, then graph exponential functions using transformations. This is just 4 to the x, plus 3. The plus 3 just moves the asymptote and all the points up 3 units. So instead of the x-axis being the asymptote, it's going to be at y equals 3. So like here. And then, you'd have 0, 4, which this is already there. And you'd have 1, 7. Right, 1, 7. So let's move that up to 1, 7. Make sure that's 1, 7, 0, 4. The asymptote's at y equals 3. And yeah, that would be the only transformation that occurred. Fantastic. Alright, then one more like this. Now this time though, the plus 3 is in the power, right? Instead of 4 to the x, x is replaced by x plus 3. That'll move the graph left 3 units. You don't move up or down though, so the asymptote's still the x-axis. But instead of 0, 1, you move that left 3. So negative 3, 1, right? If x were negative 3, you'd have 4 to the 0, which would be 1. And then instead of 1, 4, that would move over to negative 2, 4. So negative 2, 4, like that. So the negative 2, 4 would be on the graph. Negative 3, 1 would be on the graph. And you can plug the points in, plug in negative 2 for x, plug in negative 3 for x, and see that you get those outputs. And again, the x-axis, the x-axis. The x-axis is the horizontal asymptote still. It didn't get moved up or down. Great. And again, you can play around in Desmos, do it by hand if you want some further validation. Alright, this one. So again, the x-axis is the horizontal asymptote, so the graph, the function's got to have that a times b to the x form. You got 0, 4, so a is 4, and then 1, 8, and again that's just getting doubled, so the base is 2. So this is 4 times 2 to the x. Now you can do it do it on paper, but this is 4 times 2 to the x power. This would have 0, 4 and 1, 8, which this one does, and the x-axis being the horizontal asymptote. 4 times 2 to the x. Alright. Looks like one more of these with defining the equation. So here again, the x-axis is the horizontal asymptote, so the function's going to have a times b to the x form. A is when the input's 0, the output is -7. And then again, when x is 1, you get a double that output, -14, so the base is 2. Right, and then 2, -28. So a is -7 and b is 2. A is -7, and then the base is 2. -7 times 2 to the x. And again, you can do that by hand if you wish, but I don't know. I find this, after writing one of these out for you, I feel like it should be simple enough. Alright, then the only one we haven't finished yet is this write an exponential function from this description. Alright, so here's what I'm going to do. I'm going to write out, y equals e to the -5x. That's the beginning. It says it's vertically compressed by a factor of 6 again, but again, compress means you're really multiplying by 1/6. Right? That causes a vertical compression. Reflected across the y-axis, x gets changed to -x, so that means this -5x would get changed to +5x, and then shifted up 1 unit, so +1 after. So 1/6 times e to the 5x plus 1, that's going to be the final resulting function. Cool. Very similar to problems earlier. And then one more of these. So again, I'm just going to type out the function they gave us. Y equals e to the 4x power, and then we'll mess with it. Once again, they say vertically compressed by a factor of 5. So you should be multiplying by some number less than 1. In this case, if it's a factor of 5, you should be multiplying by a fifth. Reflected across the x-axis. Oh, the x-axis this time. So you're multiplying the whole thing by -1. So instead of multiplying by just 1/5 on the outside, you're multiplying by -1/5, right? That would cause a reflection across the x-axis. Right? A reflection across the x-axis is a vertical reflection. You're multiplying on the outside. And then shifted down 4 units. So then another vertical shift, so it's -4 after everything. Would shift it down 4 units. So I have y equals -1/5 times e to the 4x, and then -4 after. That would cause all those transformations that they described. Great. All right, and again, I'm assuming you remember all the transformations. We didn't cover all of them. We didn't do horizontal stretches or compressions here. That may come up. Just be aware of that. Go back to chapter 3 stuff and refresh your memory on transformations and how those affect the equation of a function. But yeah, that should be it for this preview version. Alright, now as I said at the top of the video, the questions I saw here may not be the same questions that you see when you work on the assignment yourself, but the objectives are the same, right? The structure should be the same. So I'm hoping that watching me do these here help me out help you out, sorry, help you out when you're working on the assignment yourself. And thank you very much for watching.